So let's talk about the law of cosine. Okay, so these formulas, when we take our test next week, I'm only going to give you the top one of each. So we have our standard form because there's a pattern to it, okay? I'm being nice and I'm giving them to you. I usually don't. So a squared equals b squared plus c squared. Notice that if this is the side I'm looking for, I'm summing the two other sides, subtracting 2 times those two sides, and taking the cosine of the angle of the side that I'm looking for. And that's the pattern with these other two as well. If, and this is typically for a side angle side situation. The bottom formulas are our alternate form. Basically what we did was we solved for cosine A, cosine B, cosine C, and ended up with these three formulas. So when do we use them? We use them when we have a side, side, side triangle. Okay, so the bottom ones, I want to look for the angles. I'm missing the angles. So therefore, that's your side, side, side scenario, and that's when I'm going to use those formulas. Let's go over a side angle side situation. So when we're solving a side angle side situation, we're looking for first the missing side using the law of cosines. The second thing we want to do is use the law of sines to find the second angle, and then just now you have two angles, so subtract those two from 180 degrees. So let's take a look at an example. Okay, example 1 says use the law of cosines to solve the triangle. Round to 2 decimal places. Let's round our angles and sides to 2 decimal places since actually let's round our angles to nearest degree. Yeah. So we're rounding the sides to 2 decimal place values if applicable, and let's round our angles to nearest degree. So let's take a look at what we have. We have angle A equals 39 degrees, and we have side B equals 21, and side C equals 42. By default, we're looking for that third side. That's where we start. Again, that formula is a squared equals the two other sides minus twice those two sides cosine of the side I'm looking for, but it's going to be the angle of that side we're looking for. So now I'm going to just do straight substitution. So a squared equals 21 squared plus 42 squared minus 2 times 21 times 42, and then cosine of 42 degrees. So let's put that in our calculator. All right, so here's our solution for side A. And the next thing we want to do, again, we want to use the law of sines to look for one of the missing angles. At this point, it doesn't matter which one we pick. We could pick B or we could pick C. So let's pick B. So let's find sine B over 21 equals sine A, which is 39 degrees, over 28.88. So we're going to put that in our calculator. Angle B is equal to arc sine 21 sine 39 degrees over 28.88. So let's put that in our calculators. Yes, we get angle B is approximately 27 degrees, and now I can find angle C. And we're also estimating that. So we have 180 minus 39 is 141, minus 27 is 114 degrees. So I found everything that I was missing. I found side A, angle B, and angle C. All right, so let's take a look at a side, side, side triangle. Remember, when you're looking at a side, side, side triangle, you begin with the law of cosines, but you begin with the angle opposite the longest side. So that's really important, so make sure that you somehow circle, highlight that, memorize that. And then from there, we will use the law of sines to find the either remaining angle, it doesn't matter which one, and then do 180 minus the two angles that we just found. So here's an example. All right, so here's our second example. We're going to use the law of cosines. We're going to use it opposite the longest side, which is this one. So I'm going to use cosine, because we're using the law of cosines, equals a squared plus b squared minus c squared over 2ab. So now let's just substitute. We have cosine c equals 11 squared plus 14 squared minus 20 squared over 2 times 11 times 14. All right, so now I want to put that in my calculator as arc cosine And make sure that you're using the right function for the negative button. Some calculators are picky on that. And let's round to, it says 2 decimal places, so let's keep that consistent. Angle C is approximately 105.63. Okay, and then just pick the next angle you want. Let's just pick B. Doesn't matter if I go for A or B. So let's find sine B over 14 equals sine 105.63 over the corresponding side, which was 20. So I'm going to put that in my calculator. Angle B is approximately, okay, so our answer is 42.39 degrees, because we're rounding to 2 place values again. And then subtract what we just got from 180 degrees. And we get 31.98 for our remaining angle, so angle A is approximately 31.98 degrees. So there's angle C and B and A. All right, let's take a look at this example. It says if you are on island B, which is here, what bearing should you navigate to go to island C? So we're interested in going in this direction. So remember, I told you when you have your bearings, do an imaginary axis, and you know you're going north, and in this direction west. So we're interested in this interior angle, but in order to find that angle, I need to find this angle inside this triangle. So we're going to use the law of cosines to find that angle. Conveniently, the way I set up this triangle, that angle is opposite the longest side, so I can automatically go there first. But say I didn't draw my triangle like this. Remember, according to the law of cosines, I have to start with the longest side to find that longest angle, and then I might have to use the law of sines depending on how the problem's set up. Okay, for this one, it's a piece of cake. I can go straight for theta because it is opposite the longest side, because I just made that problem up. So theta equals the next two. Remember this. Let's go ahead and title this A. This is little c, and this is little b. So cosine b, or cosine theta, if you want to substitute b in there, I'm okay. A squared plus c squared minus b squared over 2 times AC. Let's put that in our calculator and see what we get. Okay, so this is what we get. And now what I want is the inverse of cosine. It's 137.7 degrees. Remember, I want the bearing. Okay, so we were getting something funny. Clearly that other triangle was not drawn to scale, so this will help us a little bit better. So now I can actually see that if I'm going B to C, that's going to be in here. So this is the angle that I'm interested in. So I'm going to do the following. All right, so yes, now we realize that it's really northeast, not northwest. So let me do this in a different color. Northeast. And I set up my triangle in such a way where I am creating this 90-degree angle here. So I'm going to do, let's say, 137.7 minus 90, and we get 47.7 degrees. So north, 47.7 degrees east. Is that always the case? No, sometimes it comes out a little cleaner where our adjustments are made in opposite directions. All right, here's one more example, and this time they give us the picture that looks like it's a little bit better, and it's drawn to scale just a little bit better. A ship travels 60 miles due east, and we can see that right here. He's traveling 60 miles due east from A to B. Then adjust its course northward as shown in figure 6.14 after traveling 80 miles in that direction. The ship is 139 miles from its point of departure. So this is a side. Describe the bearing from point B to point C. So if I'm interested in that, so let's go ahead, let's draw an axis on here. So go like this. This is the angle I'm interested in, right? Do you guys see that? So I just went ahead and I adjusted it. This is clearly 90 degrees here because of the way I drew it. So I want to find this angle in here. But in order to find that angle, I need to find the complete angle B using the law of cosines. So let's go ahead and find the law of cosines. So I'm going to find angle B, which we said was cosine B, equals. And then if it helps you, let me go back here. Oh, it's already labeled. So we already have B. B's labeled. So I have A squared plus C squared minus B squared. So 80 squared plus 60 squared minus 139 squared over 2 times 80 times 60. Okay, put that in your calculator. 6.15. Okay, good. So that's what we get for that proportion. And then the next thing we want to do is do our cosine to that, and we get angle B is approximately 166.15. And again, we're going to subtract 90 from that to get the bearing, and we're going to get 76.15. And in which direction are, that does not look like 76.15. All right, 76.15 degrees. And we were heading, let me bring down that picture again. We were heading northeast. So we're going northeast. All right, the last thing we're going to talk about is Heron's area formula. All right, so what we want to do is we want to first find S. Basically, you take all three sides, A, B, and C, then divide by 2, and then you plug it in here. So area is equal to the square root of S times S minus side A times S minus side B times S minus side C. All right, so let's take a look at this example. It says find the area of the triangle with the given side lengths. So let's take a look at the first one. So the first thing I want to do again is I want to find S. S equals, add the sides, so 5 plus 7 plus 10. We're dividing that by 2, that's 11. And then area is equal to the square root of S, S minus A, S minus B, S minus C. Put that in your calculator, that's the area. And 16.25 units squared. Because we're talking about area, my units weren't specified, so let's put units squared. All right, let's take a look at B. Let's say this is in miles, guys. Okay, so again, we want to solve for S first. S equals 3.05 plus 0.75 plus 2.45. Divide that by 2, and we get 3.125. Now we're going to find the area. That's 3.125. Keep touching that. I have to put this back in. All right. And that's it, guys. That's all. Yeah. You're welcome. Okay, so right now for the next 10, 25 minutes, no, I'm just kidding. This isn't GH. This is I. So for the next about 18, 20 minutes, we're working on this assignment. Make productive use of your class time, Cedric. I got 0.6129.
Yeah, I got 0.62.
I got 0.616.
It depends if were you rounding before, or did you keep your stored answers? Okay. So I have an 83. I'm assuming that you have a better calculator in front of you than me. And you got the same answer as me? What do you have? What does it say at the top? Okay. Yeah, it might have been like a little input there, because you know I do get picky with the rounding. So make sure you're storing your answers, and then just go back, Lynn, and check. Okay? Alright guys, that's it. Make productive use of your class time. tomorrow, I know we have a weird schedule, so that's why we're just using class time to work on the problems. Mass. And then on, what day is that? Thursday, I'm going to torture you with all the notes for 6-3, sorry. But then Friday, you have time to work on the assignment. Tuesday, Wednesday, we're reviewing. Thursday's test.
So when is the day that we don't have school? Is it Friday?
Monday.
I mean, give them what they ask
Don't worry, we're almost to chapter 7, and the first sections are easy, guys, okay? It's like linear algebra. We get a nice little break. You don't. But you need to know it. I miss you, Ricardo. We'll do a party for you, okay? We'll do a party. On the 13th, since I'm not here on the 14th, we'll do a test day. Alright, let me log on and see what's going on with my videos.
I just figured out how to do